Imagine a world where artificial intelligence models are not only intelligent, but also incredibly power-hungry. A recent study has revealed that open-source AI models consume significantly more computing power than their closed-system counterparts, raising important questions about the true cost benefits of these models. But here's where it gets interesting. The findings suggest that the assumption that open-source models are more cost-effective may not be entirely accurate. The study, conducted by Noose Research with the help of independent analysts, compared 19 different reasoning models, testing them on a range of tasks, including knowledge questions, mathematical problems, and logic puzzles. The researchers focused on token efficiency, which measures the number of units of computation a model uses to produce an answer. And this is the part most people miss. The results showed that open-source models used between 1.5 to 4 times as many tokens as closed models, with some systems using a staggering 10 times more tokens for basic knowledge tasks. But what's even more surprising is that the added computation often translated into higher overall costs despite lower per-token pricing. Large reasoning models, designed to think step by step, were found to be particularly inefficient, producing long reasoning trails for problems that required little thought. In some cases, models consumed hundreds of tokens just to answer a straightforward question, such as the capital of Australia. For instance, a model might use 100 tokens to answer a simple question, while a more efficient model might use only 10 tokens to produce the same answer. The performance of different providers varied significantly. OpenAI's O4 Mini and GPT-OSS models were found to be among the most efficient, particularly in mathematics, using up to 3 times fewer tokens than other commercial systems. Nvidia's Llama 3.3 Nematron Super 49B V1 topped the open-source list, while some of Mistral's recent releases were marked as outliers for heavy token use. However, it's essential to note that these findings might spark controversy among AI enthusiasts, as some may argue that the benefits of open-source models outweigh their increased computing power consumption. In logic problems, the difference between open-source and closed models was narrower, but still present. Adjusted versions of puzzles like Monty Hall revealed that models relied on training memory until changes forced them to reason properly. When problems were altered, token use rose, highlighting the need for more efficient reasoning mechanisms. But here's the thing. The research team had to rely on completion tokens to measure efficiency because many closed providers hide their raw reasoning steps. Some compress internal thinking into short summaries, while others use smaller models to record reasoning in compact form. Completion tokens, billed directly to customers, gave a clearer picture of the actual computing effort. The testing also included math competition problems with altered variables to prevent memorized answers. The results showed that most models attempted to solve problems rather than recall them, but the spread of token use was wide. OpenAI's efficient models stood out for keeping costs lower overall, even with higher per-token rates. This raises an important question. Should enterprises prioritize accuracy and per-token pricing when choosing systems? Or should they consider computing overhead as a critical factor? The answer might not be as straightforward as it seems, and it's essential to weigh the pros and cons of each approach. The study suggests that enterprises need to look beyond accuracy and per-token pricing when choosing systems. Computing overhead can mount quickly and shift the balance of total costs. Closed providers appear to be reducing token use with each update, while some open systems have been moving in the opposite direction by generating longer reasoning trails. This could be a point of contention among AI developers, as some may argue that the benefits of open-source models outweigh their increased computing power consumption. the complete dataset and evaluation code have been made public, and researchers believe that future development should target efficiency alongside accuracy. Shorter, denser reasoning could help keep costs down and preserve performance on complex problems. The findings point to efficiency as a central factor in determining which models can be scaled for widespread enterprise use. But what do you think? Should efficiency be the top priority when developing AI models, or are there other factors that should take precedence? Share your thoughts in the comments below. As we move forward in the world of AI, it's essential to consider the implications of these findings. Will open source models continue to dominate the market? Or will closed systems become more popular due to their efficiency? The future of AI is uncertain, but one thing is clear: efficiency will play a critical role in shaping the industry. So stay tuned for more updates on this topic and join the conversation in the comments section. Read next: Sam Altman opens up on Google, GPT-5 and OpenAI's next moves. Or ChatGPT Mobile surpasses $2 billion spending and becomes fastest app to hit 1 billion downloads.